Okay, in this video I'm going to do part B of problem 3 here, and it says to prove if true and otherwise find a counterexample. Part B says the product of two integers is odd if and only if at least one of them is odd. The product of two integers being odd, we're going to call that P, and if and only if at least one of them is odd, we're going to call that Q. And so this statement is P if and only if Q. Okay? And so that translates to, that is equivalent to P implies Q and Q implies P. I claim that this is false because in fact the correct statement for Q, if this were to be a true statement, the product of two integers is odd if and only if both are odd, and you can see that here with our table here. The only time we get the product, the multiplication, to be odd is when both are odd. And so the correct statement here, if you were to turn this into a correct statement, would be both of them are odd. When it says at least one of them is odd, it leaves room for the situation where one's odd and one's even, in which case the product won't be odd. And so what I'm going to do is I'm going to disprove this by disproving one of these two. I'm going to disprove this one that says that if at least one of them is odd, then they're both integers. Then the product is odd. Okay, so Q, so we want to disprove if Q then P, so we show an example where Q is true and not P is true. And that's how you disprove an if-then statement. True premise, false conclusion. I claim that the counterexample is x equals 2 and y equals 3. Then we've satisfied Q because at least one of them is odd, and P is false. Why is P false? Because the product is even. Okay, and so that is not P, and so we've done it. That's a valid counterexample to this statement. Okay, hope that helps.